the temporary connection. With the robot confirmed safe, the PLC physically commands the machine's automatic door to close. It then sends one final 24-volt pulse back to the CNC's input panel, authorizing the computer to resume the G-code cycle. The handshake is complete. A request was generated, physical reality was audited, the action was executed, and the entire system reset for the next cycle. While the logic looks flawless on a screen, the inside of a machining cell is a harsh, messy environment. A buildup of metal chips or a spray of coolant can easily blind a proximity sensor. When that happens, the PLC does exactly what it is designed to do. It stalls the handshake and safely halts production. This graph shows the electrical realities of a factory floor. Notice the messy, fluttering voltage lines and erratic spikes. These are phantom signals created by electrical interference from heavy drive motors. To prevent the machinery from reacting to these false positives, programmers write a debounce timer directly into the ladder logic. With debounce logic active, a signal must hold a steady voltage for a defined duration, often around 500 milliseconds, before the PLC accepts it as true. Actively filtering out physical debris and electrical noise is what separates a fragile lab experiment from a robust, production-ready manufacturing cell. However, despite rigorous interlocks and debounce timers, PLC ladder logic is still ultimately software, and in industrial engineering, software is never entirely trusted with critical life safety. This diagram outlines the emergency stop or e-stop circuit. Notice how it bypasses the software logic entirely, routing straight to the hardware. These hardwired safety loops do not ask the PLC for permission to stop the machine. When triggered, they physically sever the high-voltage power lines to the servo amplifiers instantly. As automation technology matures, the industry is moving away from massive physical bundles of 24-volt relay wires. Modern integrated systems now abstract these discrete physical signals, packaging them into heavily encrypted Ethernet data packets that travel across single, high-speed cables. Yet, whether passing current through a copper relay or transmitting data packets across a digital network, the underlying architecture holds firm. The strict logic of the handshake, request, verify, execute, and reset, remains the absolute bedrock of automation safety.
Thanks for watching. Stay tuned.